Hi, this presentation is a quick overview about making sedimentary rocks, titled Construction Through Destruction, Making Sedimentary Rocks. Destructive geologic processes produce the material needed to make sedimentary rocks. These processes are the opposite of the constructive geologic processes that add new rock to the Earth's crust and build up the crust in some way. Think of mountain building or a volcanic eruption where the lava coming out of the volcano solidifies into new rock. Destructive geologic processes are those that break down rock, resulting in the wearing down of landforms at Earth's surface, such as you see in this photograph here of Bryce Canyon National Park. The strata, the layers of sedimentary rock, are being worn down steadily over time, resulting in these deep, steep-sided canyons. Eventually, all this rock will be broken down and worn away. Step one in the destructive geologic processes is weathering, the breakdown of rock. Weathering happens mechanically or chemically. Mechanical weathering is where something big, like let's say a mountain or a cliff face, is broken down into smaller pieces, which we call grains. Think of a grain of sand. An example of how mechanical weathering works in nature would be frost wedging. Water within cracks of rocks freezes and expands, expanding or wedging the crack open. Here is a photograph of water in an ice cube tray and how the water expands in size when it goes from being a liquid to a solid. When this happens in nature, water within cracks in rock freezes and expands, the cracks widen, and the rock gets broken apart. Chemical weathering is when rock is dissolved or altered in some way that the rock becomes weaker. An example of this is dissolution, which you might recall from our discussion about minerals. When hydrochloric acid is applied to the mineral calcite, it reacts with the acid and dissolves. Calcite is the main mineral in the rock limestone. So limestone is dissolved over time when it's exposed to acidic water. And there's a lot of acidic water in nature. Perhaps you've heard of acid rain. Mass wasting is the second step in the destructive geologic processes. And this is when gravity pulls weathered rock downhill. An example of in this way, that mountainside is being worn down. This is a dramatic, very, very fast geologic process we see in the video. Step three, erosion. So the loose material, the sediment that has been produced through weathering and mass wasting, is then transported. And this typically happens in rivers. Rivers pick up and move the sediment along through a process that we call erosion. Erosion further weathers and breaks down the sediment to smaller and smaller pieces. And in doing so, as the streams flow over the landscape, they wear down the landscape, they destroy it. This is also called erosion. So we have an example of two different types of rivers here. One is contained in this very narrow, steep-sided valley. And over time, this valley is going to get deeper and wider as the water, which contains all kinds of grains of sand and rock, is flowing through there and doing erosion, wearing down the rock. We have a stream flowing more slowly with less energy, but nevertheless, the stream, as it winds its way back and forth across this valley, is widening the valley. And over time, you can see these low hills here, those will get worn down because of the stream flowing through this area. All the material, all the rock and minerals that are transported through the processes of first weathering, producing the sediment, mass wasting, taking the sediment downhill, and then erosion, mainly through streams, picking up and moving the sediment, the streams eventually come to a place where they slow and end, where they stop flowing and the load of sediment is deposited. Your stream is entering the ocean. That's the ultimate destination for most rivers. As the stream enters the ocean, it slows down. As it slows down, it loses energy. As it loses energy, the sediment falls out of the water and is deposited. It is laid down in layers at the bottom of the ocean floor, at the bottom of a lake, at the bottom of a slow-moving river. And in this way, the sediment piles up in layers. This dropping off of sediment leads to step 5, which is what we call lithification, the transformation of sediment into rock. Lithification is the process you want to have in your mind. For igneous rocks, the comparable process was crystallization. For sedimentary rocks, we want to be thinking of lithification. This involves compacting and cementing to make clastic or detrital sedimentary rocks. In this photograph, you see the result of that deposition, compacting and cementing together. We end up with these layers, which we call stratification. This is the most obvious characteristic of sedimentary rocks. So in nature, if you see layers like this, you should be thinking, those are sedimentary rocks. To make chemical sedimentary rocks, that involves a different process that we call precipitation. Precipitation happens in the ocean through or from sea creatures which secrete skeletons around their bodies. You're familiar with seashells or coral? Well, that's how they're made. There's a little jelly-like soft-bodied creature that is completely defenseless. So to create a defense around it, it creates an exoskeleton. As opposed to us, we have an internal skeleton. They create this exoskeleton or shell around themselves to protect themselves, and that is made through this process of precipitation, where minerals are crystallizing out of water. The geographic location where a sedimentary rock forms is called its depositional environment or the origin for a sedimentary rock. This can happen on land, up near the mountains, out of the mountains, in lakes, in deserts, within a river itself, in the shallow or the deep sea. Your textbook has a nice illustration of this that you will be learning more about as you do the reading and the laboratory activities.